Okay, so here we have a quite challenging vector proof question. We've got a diagram, we've got the basic information, and in part A we've got to work out a vector in terms of these algebraic vectors A and B. We've got to simplify our answer. In part B we've got to show that M, N and C lie in a straight line, and the show that there indicates that we've got to understand how to do a vector proof. So this is a vector proof question, fairly challenging, the sort of thing that's going to be tackled by students who are trying to get an A or an A star. Let's have a look at the examiner's remarks then. And the examiners say that a majority of students didn't attempt this question. Correct responses were rare, and there were quite a lot of errors. So the errors included giving vectors as a mixture of forms, A plus A to N for example, and in part B reverting to doing the work on the diagram or using a ruler. Well, you can't use a ruler because it's not drawn accurately, and the point about mixing terms just indicates that people didn't understand how we work with vectors and what the notation means. So you really do need to understand vectors fairly thoroughly to tackle a question like this, but once you have understood it, it's a fairly straightforward, fairly predictable kind of question to work out the correct answers for. Okay, so it requires some thinking, so we're going to look at our diagram, we're going to look at the information, and it's not automatic, we'll have to think about how best to answer it. So we're going to start with Mn, so let's write down M to N, which hasn't been given to us, so let's draw that straight away on the diagram. So from M to M, and draw an arrow to indicate that we're going in this direction. Now to get from M to N, we could go around in this direction here, but the most sensible way is to go up and then down. So M to A, like this, so M to A, and then A to N. Now we haven't got a vector A to N, so we're going to overlay now a vector on our diagram. And if this is A to N and N is a midpoint, then N to B, N A to N, let's just make a note of that, is going to be equal to N to B. So that's indicated that N is a midpoint. Now, we've got this vector here from M to A, but what we don't have is A to N. How are we going to get A to N? Well, we know that A to B is available. So to get from A to B, we can go from A down to O and from O to B. And so we've got all the vectors in place to do that. So that's the first thing we're going to do. Okay, so A to B is equal to, so we start then working in terms of A and B. So we're going in this direction, so it's going to be minus A and minus 3A and plus 2B. Okay, gather up our A terms. We've got minus 4A plus 2B. So now we've got an expression of A to B. Well, we actually want A to N. So to get A to N, because N is a midpoint, we're simply going to halve A to B. And that's going to equal minus, so half times minus 4 is minus 2A, and half times 2B is going to be just B. So there we are. Now we've got our two vectors. We've got M to A, this one, and we've got A to N. So we can just add them together. So M to A is A. And A to N, well, that's minus 2A plus B. So that gives us a minus 2a is minus a plus b. And that's completed our answer. So if we underline that, that's our answer for part A. Okay, let's just underline it once. Okay, so let's move on to part B. Now in part B we've got to show that, and show that always means proof. We've got to prove M, N and C lie on a straight line. So it's a straight line. So clearly they share a common point. So we could deal with that now. Let's first of all then write, whoops, okay. Well, if we draw a vector, it's probably going to be the easiest way to show this as a proof. So we draw a vector from N to C. So we've now got two vectors, M to N and N to C. So we can say straight away that M to N plus N to C equals M to C So now, because these are in the middle here, therefore N is common. Okay, so that's the first part of what we've got to prove. We've got to make sure, first of all, that N has been shown to be on that line, connected to both M and N and N and C. So what we haven't done, though, is shown that they're on a straight line. So it's important that it's straight. And we haven't shown that because, obviously, this could be a bent line. So even though they're sharing a common point, this might not be, you could say, 180 degrees going around from here to here. So it's not necessarily a straight line. Now, to prove that, we need to show that these two vectors, Mn and Nc, are parallel. So prove Mn is parallel to Nc. Now it's parallel. It's parallel not only if they're apart, but also if they're lined up together. They're actually sort of sitting on top of each other, or end to end like this. So that's still parallel, because parallel just means pointing in the same direction. Now, if they're parallel, what we will have is M to N must be equal to some constant K times N to C. So that's what we've got to prove. Okay? If they're parallel, then Mn must equal some scalar times N to C. Now, we haven't yet found N to C. Okay? We've got M to N in the first part of our question. We haven't got N to C. So N to C is what? Well, it's got to be N to B. There's only one root here. It's got to be N to B plus B to C. We've got B to C already. What we haven't got is N to B. But N to B is equal to A to N. Okay? So we can write A to N plus B to C. Because this is the midpoint of this line. So A to N, we've already written down, A to N is equal to N to B. So now we can substitute in A to N, which is minus 2A plus B plus our BC, which is on our diagram, equals B. That gives us minus 2A plus 2B. And we're nearly there. What we have to deal with now, though, is this K. Well, K it must equal a half, and we can tell that from looking at what we've got to prove. So NC is this expression here, minus 2a plus 2b, and MN, which was back here, is minus a plus b. So that's going to be a half of this expression here. Okay, so therefore we'll say let k equal half. Okay, and then rewrite out m to n equals a half of n to c, which is this expression here. So minus 2a plus 2b. And so now all we've got to do is, as it were, expand the bracket. So minus 2 times a half, or half times minus 2, is going to be minus 1. So minus a. And half times 2 is just 1, so b. So mn is minus a plus b, and so we've proved, therefore, that mn is parallel to nc, which was required, which is what we had to prove. Okay, so what we've got here is a two-part proof. The first part was very easy. We had to prove that n was common, and we did that here. And then the second part, a bit trickier. We had to think this through a little bit more, do a bit of calculation, and then we proved that mn is parallel to nc. So if they're both parallel and n is common, then m, n and c do indeed lie on a straight line.